My name is Uche Martins. Welcome to physics class. Today we'll be taking the topic electromagnetic wave with the theme waves motion without material transfer. By the end of this lesson, you should be able to understand and distinguish between electromagnetic and mechanical waves, list the types of radiation in the electromagnetic spectrum in order of increasing wavelength, state the uses of electromagnetic waves, and solve problems relating to electromagnetic waves. Some of the concepts we'll be looking at: electromagnetic waves, mechanical waves, differences between electromagnetic wave and mechanical waves, electromagnetic or the AM spectrum, electromagnetic radiation, AMR, and the uses of electromagnetic radiation. The combination of electric field and magnetic field waves is called electromagnetic wave. From electromagnetic, combination of electric field waves and magnetic field waves gives us what? Electromagnetic wave. Most electromagnetic waves like radio waves, microwaves, infrared radiation, visible light, ultraviolet radiation, X-rays, gamma rays. Most of these electromagnetic waves transport its energy through a vacuum at a speed 3 times 10 raised to the power 8 meter per second, which is represented by a symbol C. What am I telling you? That the speed at which most electromagnetic waves propagate is as a speed of light with a value 3 times 10 raised to the power 8 meter per second. What is electromagnetic waves, AM wave? Electromagnetic waves are those waves that do not need a material medium for its production. However, take note that we know they do not need a material medium for them to be produced or for them to be transferred from one form to another. Since we understand that waves has to do with the transfer of energy from one region to another. But however, if it comes in contact with a material medium, the actual speed of propagation of electromagnetic wave is dependent upon the optical density of that medium. Therefore, the speed through the material medium is less than the speed of C. Initially, we know that all electromagnetic wave travels with the speed of light with the symbol C as 3 times 10 raised to the power 8 meter per second. Now, when it comes in contact with a medium, it now travels with a speed less compared to what? 3 times 10 raised to the power 8 meter per second. What are mechanical waves? Mechanical waves are waves that require a material medium for its production, e.g., sound waves. Without water, sound waves cannot be produced. Waves produced in ropes or strings. When you are skipping, the waves produced by the vibration of the particles of the ropes is a mechanical waves because the material medium there is the particles of the ropes. And also sound waves. What are some of these differences between mechanical and electromagnetic waves? Electromagnetic waves do not require a material medium, while mechanical waves require what? A material medium for its propagation. Electromagnetic wave travels in a vacuum, an open space, while mechanical wave, they do not travel in an open space. Electromagnetic waves are affected by the varying magnetic and electrical field properties from the word electromagnetic. So the electrical and magnetic properties of the field affect that of the wave. But mechanical wave is only affected or depends on the elastic property of the medium through which the wave passes. Electromagnetic waves are produced by the vibration of charged particles, electricity, while mechanical waves are caused by the amplitude of the medium and not frequency. Electromagnetic wave travels with speed of light with the symbol C, like we explained, with the value 3 times 10 raised to the power 8 meter per second, which is 3.0 times 10 raised to the power 8 meter per second. But mechanical wave travels with a speed less than that of the speed of light. Electromagnetic waves are transverse waves. That means they are transverse waves, and we've defined transverse waves as waves that travels perpendicular to their source of production. So they can be polarized, while mechanical waves can be transverse, can be longitudinal, and also can be surface waves. Electromagnetic spectrum. What is electromagnetic spectrum? Electromagnetic spectrum is the term used to collectively describe the electromagnetic radiation with respect to their frequencies and wavelength. Electromagnetic waves was first predicted theoretically by a British physicist, James Clerk Maxwell. He also proposed that light itself was electromagnetic radiation. Now, the experimental evidence for the existence of EM, which is electromagnetic wave, was provided by German physicist Heinrich Hertz. This shows the different types of electromagnetic radiation are broadly classified into the following: gamma ray, X-ray radiation, ultraviolet rays, visible radiation, infrared radiation, microwave, radio waves. Gamma ray. Let's look at some little properties of gamma ray. Gamma ray fall in the range of electromagnetic spectrum above soft X-rays. Gamma rays have frequency greater than 10 raised to the power 18 cycles per second or Hz, and a wavelength less than 100 picometers or 4 times 10 raised to the power minus 9 inches. A picometer is 1 trillionth of a meter. Also, gamma ray, they occupy the same region of the electromagnetic spectrum as at hard X-ray. Also, X-ray radiation. Let's look at some things. X-ray radiation is a form of electromagnetic radiation. Most X-ray have a wavelength ranging from 0.01 to 10 nanometers, corresponding to a frequency range of 30 pentahertz or 30 exahertz. 3 times 10 raised to the power 16 and 3 times 10 raised to the power 19 Hz. X-ray wavelengths are shorter than those of UV, which is ultraviolet rays, and typically longer than those of gamma ray. Look at the spectrum. You can find X-ray. This shows that X-ray has longer wavelength than that of gamma ray, and gamma has a greater frequency as that of X-ray. That's why this statement said X-ray wavelengths are shorter than that of ultraviolet ray. This is the arrangement of electromagnetic spectrum in the order of their wavelength, considering gamma ray with the smallest to radio with the largest, and considering the frequency with gamma ray with the largest and radio with the smallest. Ultraviolet rays. An ultraviolet ray is an electromagnetic radiation with a wavelength and frequency of 10 nanometer and 30 pentahertz to 400 nanometer and 70 terahertz, shorter than that of visible light but longer than that of X-ray. Ultraviolet ray, it has a shorter wavelength as that of visible light but longer than X-ray. Infrared radiation. Infrared radiation is an electromagnetic radiation with longer wavelength. You can see infrared here. It has a longer wavelength than the rest electromagnetic radiations. Longer wavelength than those of visible light and is therefore invisible, although it is sometimes loosely called infrared light. It extends from a wavelength of 700 nanometers with a corresponding frequency of 40 terahertz to 1 million nanometer with a corresponding frequency of 300 gigahertz. Terahertz radiation. Terahertz radiation is an electromagnetic radiation that has a frequency ranging from 0.3 to 3 terahertz and a wavelength ranging from 1 millimeter to 0.1 millimeters. Microwave. Microwave is an electromagnetic radiation with wavelength ranging from 1 meter to 1 millimeter and a frequency between 300 megahertz and 300 gigahertz. Radio wave. Radio wave are a type of electromagnetic radiation with a wavelength in an electromagnetic spectrum longer than infrared. This is radio wave. It has longer wavelength than infrared. Radio wave have a frequency as high as 300 gigahertz to as low as 3 kilohertz. You can see as there is an increase in the wavelength of this electromagnetic radiation, there is a decrease in their what? Frequency. Electromagnetic spectrum. The whole range of electromagnetic wave is known as electromagnetic spectrum. Electromagnetic waves are classified based on their increasing order of wavelength, with gamma ray having the shortest wavelength and the largest frequency, and radio wave having the larger wavelength and shortest frequency. These waves have the same wave properties. They have the same wave properties like reflection, diffraction, refraction, interference, and polarization. Electromagnetic spectrum. Their wavelength and frequency are connected with the relationship C. Like we said, C is a symbol used to represent the velocity of all electromagnetic radiation equals to lambda F. Lambda is our wavelength, while F is our frequency. I know C, which is our wave velocity, which is the electromagnetic velocity, has a value as 3 times 10 raised to power 8 meter per second. So expressing the wavelength lambda now, it will be equal to C over F, which is the frequency. Let's take an example. A certain radio station produces radio wave, which is an example of an electromagnetic wave, has a frequency of what? 4,000 kilohertz. Calculate the wavelength of the radio waves. When you hear radio waves, it's a good example of what? An electromagnetic what? Radiation, which will have a speed C of 3 times 10 raised to power 8 meter per second. So the expression to calculate for the wavelength becomes C equals to lambda F. So lambda is equal to what? C over F, which is the wavelength. The frequency has been given as 4,000 kilohertz, expressed as 4,000 times kilo, 10 raised to power 3. This becomes 4 times 10 raised to power 3 times 10 raised to power 3, which becomes 4 times 10 raised to power 6. So C is 3 times 10 raised to power 8. So lambda is equal to 3 times 10 raised to power 8 over 4 times 10 raised to power 6. At the end, we get lambda is equal to 150 over 2, which becomes 75 meters. So our wavelength for that radio wave is 75 meters. Gamma ray. What are some of the uses of electromagnetic waves? Gamma ray, for instance. Gamma ray can kill normal cells, cause cancer, and treat cancers and tumors. It detects cancers and tumors in our body. They are used to sterilize medical equipment, drugs, and food. X-ray. When you hear the word X-ray, they have great penetrative power, which is used to detect bone fraction. When you hear someone say, I'm going for an x-ray, what the person is simply saying, I'm going to scan my body with an electromagnetic radiation, which is x-ray, to see how my bones look like. So it can use to detect fractions in bones. Also, it can use to detect flaws, holes, openings. It can use to detect concealed weapons in baggages. For people in airport, most times they pass their bag and they allow them to go through a particular area which is full of x-rays, radiation. So it can show out concealed materials, even your key, your phone, and even if you are carrying a weapon or a gun, it will show it. Still on the uses of electromagnetic waves, let's look at ultraviolet rays, the uses. UV, ultraviolet rays, are used as germicides in destroying bacteria, viruses, and molds in air. UV synthesizes vitamin D in our skin. It's also a painkiller. It is used to detect forged banknotes, fake currency. If they are passed through the UV light, it will differentiate between a fake and an original currency. Also, infrared radiation, the uses. It is used to cause heating. It's also used for night vision and security cameras, as infrared radiation is invisible during the daytime. Uses of microwaves. Because of the frequency of microwaves, it easily passes through atmosphere, clouds, and radio wave, and it is used mainly for communication. Let's take a look at the summary of this topic. Electromagnetic waves are waves that do not require a material medium for its propagation. Mechanical wave. Mechanical waves are waves that require a material medium for its propagation. Electromagnetic spectrum is simply a collective description of electromagnetic radiation with respect to increasing wavelength. What are some examples of electromagnetic waves? We have the gamma ray, we have the radio wave, we have the microwave, we have the visible light, and we have the X-ray. Let's take this question. Elizabeth radio is transmitting with an unknown frequency with a wavelength of 150 meters. Find the frequency of transmission. Take C to be equal to 3.0 times 10 raised to the power 8 meter per second. A, 2000 kilohertz. P, 2 kilohertz. C, 200 megahertz. D, 2 hertz. Let's look at the solution. Elizabeth is transmitting with an unknown frequency with a wavelength. Take note, wavelength, lambda is equal to 150 meter. They say find the frequency F. Take C, which is the speed, as 3 times 10 raised to the power 8 meter per second. Remember that our C is equal to lambda F, wavelength times frequency. So our frequency will be equal to C over lambda. C has been given as 3 times 10 raised to the power 8 all over the wavelength has been given as 150 meter. So this is equal to 300 times 10 raised to the power 6 all over 150. 150 into 300 is 2. We are left with 2 times 10 raised to the power 6. So this is simply 2 times 10 raised to the power 6 ends as our frequency. But let's look at the expression there. We know that 10 raised to the power 6 is mega and 10 raised to the power 3 is kilo. Now, if we have 2000 kilohertz, it is the same thing as 2 times 10 raised to the power 6 hertz. So the correct option is A. Arrange the following groups in increasing order of their wavelength. A, gamma ray, radio waves, X-ray. B, radio waves, X-ray, gamma ray. C, gamma ray, X-ray, radio waves. D, X-ray, radio waves, gamma ray. The correct option is C. Remember, we are to arrange the following groups in increasing order of their wavelength. Gamma ray has the smallest wavelength, followed by X-ray and radio wave. From gamma ray to radio wave, the wavelength increases in the electromagnetic spectrum. We have come to the end of this lesson, and we'll be able to understand the difference between electromagnetic and mechanical wave, the symbol C, which represents the speed of electromagnetic wave, and also the electromagnetic spectrum in order of increasing wavelength. Thank you very much, and see you in the next class.
If you enjoyed this video, hit the like button, drop a comment, and subscribe to our channel. You can also turn on notifications to stay updated on new videos on this channel. This Brain Friend video was brought to you by Synforest. For more of these amazing e-learning videos, get your copy of Brain Friend. With more than 1,000 e-learning videos, over 74,000 test items in more than 40 subjects, a career counseling guide, and many other amazing features, BrainFriend remains your foremost e-learning and exam preparatory software. BrainFriend. Learn better, make excellent grades.